In this video, we're going to look at 12 questions under arithmetic sequence or progression, as you might want to call it. So this is the first quarter of the 12 questions. Now question 1 says, the ninth term of 1 over 3, 1 over 7, 1 over 11, 1 over 15, and 1 over 19 is dash. So what is going to be the ninth term of this sequence? How are we going to solve it? Now basically, you need to know that for an arithmetic sequence, the nth term is actually written as a plus n minus 1 multiplied by d, where a is the first term of the sequence and d stands for the common difference. Now you could get d by subtracting, you could get d by subtracting t1 from t2. Or if you have t3, you could subtract t2 from t3. If you have t4, you could subtract t3 from t4. That basically gives you the common difference for the sequence. So this is actually what we need. We need to find what the first term is, what the common difference is, and then what n is. Well, we might not really need to find that because that was actually given to us. So n would actually be 9. So Tn should be the same thing as T9. Now, what is the first term? First term is actually T1, and that is 1 divided by 3. T2, that is 1 over 7. And we have T3 to be 1 over 11. T4, we got 1 over 15. Now, if you notice the pattern that is being created here, there is actually an increase of 4 on the denominator side. So from 3 to 7, if you added 4, that is going to give you 7. If you added 4 to 7, that gives you 11. And if you added 4 to 11, that gives you 15. It's the same case as adding 4 to 15, and that would actually give you 19. So basically, we know that the denominators are increasing by a value of 4. Now, if we wanted to find the common difference and used T2 minus T1, that wouldn't actually give us 4, because if you subtracted 1 over 3 from 1 over 7, that should give you minus 4 divided by 21. This seems not to be the answer. So what I'm just going to do is I will change the first, second, third, fourth, and the fifth terms and write them this way. So let us say arbitrarily T1 is equal to 3. And let us say that T2 is equal to, that is 7. Then let's say that T3 is equal to 11. And let T4 be equal to 15. T5, let us make it 19 rather. So if we did this, this would actually be easier or more basic to solve. So we have A to be 3, and D will be the difference between succeeding terms. So that basically is going to give us 4, as you can see. So this gives us 4. Now D is equal to 4. So we have A is equal to 3 and D is equal to 4. So we can now find the ninth term. So that is going to be A plus 8D, right? Because if I subtracted 1 from 9, this is basically going to give me 8. So A is 3 and D, that is 4. So we have 3 plus 32. Therefore, T9 is equal to 35. But as you know, we didn't actually take it from the original question. So we actually changed this into a real form other than fractional forms. So we actually need to take this back into its fractional form. So most likely T9 should actually be 1 divided by 35, because that obviously is the pattern that is being created within that sequence. And so that basically will be the answer to this question. So let us try the second question. Now for the second, they said the sequence 28, 22, x, y, 4 is an AP. So we are required to find the values of x and y. So the first term, which is T1, is equal to 28. And T2, we have a 22 there. So T3, that is going to be x. And T4, that is y. How about T5? So that will be 4. So as you can see, there is actually a decrease in the terms that are being formed. That means the common difference should be a negative number. Now you know that the common difference should basically be D, and that is T2 minus T1. You could also have T3 minus T2. In this case, we could just use this once because this would actually give us numerical values. So we have T2 to be 22 and T1, that is 28. Now, if you subtracted 28 from 22, that basically should give you negative 6. Now, A, which is the first term, is 28, right? We might not even really need the first term, but let us just go on. Now, if we know that the first term is 28 and the common difference is negative 6, we could actually use it to find what the third term is going to be. And the third term is actually supposed to be T3. And we know that T3, this should be A, so we got n minus 1, and this is D. Now, if n is 3, this is going to be 28 plus, so we got 3 here, and this is minus 1, and D, we got negative 6. So this should be 28, and this will be 2 multiplied by negative 6. And 2 multiplied by negative 6, that should give us minus 12. So we have 28 minus 12. So this basically should give us 16. That means T3 is equal to 16. So X basically will be 16. Now the next thing we need to do is to find what Y is going to be. Now there is actually a very easy way that you could use to find what Y is. You could also use this formula where Tn is equal to A plus n minus 1 multiplied by D. Or you could decide to use another one, which is called the arithmetic mean. Now, how does that work? Now, for an arithmetic progression, you have something that is called an arithmetic mean. So an arithmetic mean is in such a case that if you had 3 consecutive terms which are present within an arithmetic sequence, let us say they are x, y, and z, then the middle term could actually be an arithmetic mean if you added the first and last term and divided it by 2. So that is basically how to find it. How about if we had x, y, z, and let's say we had m and n. What is going to be the arithmetic mean for this sequence? So if we take it that this is an arithmetic sequence, this is actually possible. We could say z is equal to x plus y plus m plus n, and this will be divided by 4. So if you are able to add this stuff together and divide it by 4, that should give you what z should be, which is always going to be the middle term. Now you could also change it in this way. Now if I eliminated n away from here, it's also very possible for you to find some arithmetic mean there. So we could say that y plus z is equal to m plus x and divided by 2. So that is on a more advanced form. So let us just leave that one. Now let's use this formula. We know that y is actually supposed to be x plus z divided by 2. Now what is x? We have actually found x to be 16. Now z is actually the last term, which is the fifth, and that is going to be 4. Z is equal to 4. So y is going to be 16 plus 4 divided by 2. So this basically gives us 20 divided by 2, which is going to be 10. So that is the answer to the question. Y is equal to 10. Now let us go find the answer to the third question. So the third question says, if the first, second, and last terms of an AP are 5, 9, 101 respectively, find the total number of terms in the AP. So first off, we got to write the first term. That is going to be T1. Now T1 is equal to A, and that is actually 5. Then we have T2. So in this case, we have T2 to be 9. And the last term, we do not actually know the position where the last term is. So we're just going to designate that as n. Let me rewrite that. So this is going to be 101, right? Now, we need to find the number of terms of the AP. That means we need to find the value of n. So we know what the first term is, and that is 5. Well, what is going to be the common difference? So that basically should be T2 minus T1. Now T2, we have it as 9, and T1, that is 5. So D basically should be equal to 4. Now, we know that Tn is equal to A plus n minus 1 multiplied by D. Now Tn in this case, we're choosing it to be 101. So if that is going to be 101, that means we need to find what n is. In this case, we know that A is 5, and n, we don't know what it is, and D, that is 4. So the first thing that I'm going to do is to take this and bring it to this other side. So that basically will be 101 minus 5. This will be equal to 4 multiplied by n minus 1. Now 101 minus 5 basically should give us 96. So we have that into 4. So that is equal to 4 into n minus 1. Now n minus 1 could actually be made the subject of the formula. But we need to divide both sides by 4. So if this cancels out, now we need to know what this is going to be. Now 4 can cancel into 96 and create a 24 here. So we basically have 24, and this is equal to n minus 1. So what is going to be n? Now we have 24 plus 1 is equal to n. So n is basically equal to 25. So that is the answer for the number of terms that are present within the AP, 25 terms.